So this is Mike at Avalan Wireless. Just going to be talking today about the basics of networking, and I'm going to walk through a few different main key items they're listed on the right. We're going to talk a little bit about how packets are handled very much like in the mail of old with the post office. We'll talk about how using a letter correlates to much the same as doing an IP address. And then we'll talk a little bit about how IP address ranging works, subnets, gateways, DNS, URL lookups, and then finally getting into, hopefully at the end, enough time to talk about MAC addressing and what it means to actually transport data through the internet at a packet level. So let me just let me jump right in and take a look what we've got. Sorry about that. It looks like my screen may not have been turned on quite yet. There we go. All right. So kicking to the next slide. All right, cool. So when we're talking about the good old post office, there's always three kinds of mail that we get. You either have junk mail, which is sent to your house without having an address much more than current resident of. And that would be considered a broadcast communication. And then you've got direct mail that actually got mailed to you. That's your water bill, and it wasn't mailed to anybody else, so that'd be considered a unicast packet or unicast mailing. And then you've got, so we went from broadcast to unicast, and now we've got a unique kind of unicast. Not only did it get to you, but you have to sign something, and there's going to be a card that goes back to the sender to ensure that you got it. And if they don't get their card, they're going to send it again and ask you to sign another card until they really do get their card. So much the same way all of the world of Ethernet works. It really is much the same for packet handling. So if you think back, and those of us that are pretty old can think back, if we wanted to actually think about what did we do in order to query up a browser on the internet. And this is hopefully where we'll get to at the end. But if you want to think back, I can remember in engineering school that if I wanted to get a catalog from a particular engineering firm about their O-rings, let's say that they sent, you'd actually have to go down to the library, look up in these huge books that had every company listed in it, and there's tons of them, and you look up under industrial, then O-rings, and there might be 8 different listings there, and you'd actually mail a letter to them asking for a paper copy of their catalog. Maybe you'd call a phone number. And then if you liked something in the catalog, you'd actually mail them a check with an order form, and then you might wait and wait and wait and wait some more. You certainly didn't look it up on the internet or place an order online. That's kind of how it went. Super cumbersome, particularly going down to the library to go and look up who makes O-rings. Very, very inefficient way of doing things. But nowadays, because the internet facilitates sending that same request at the speed of light, basically when you look it up, you don't have to go to the library. The internet facilitates looking up that through a search engine is your library to look up companies that make O-rings. You then immediately get an ability to see their catalog live right there in front of you, 100% up to date. And then you can order directly straight away, and it'll arrive, then 2 days later, with like an Amazon type order. Just it's from the efficiency standpoint, that's obviously what we're looking at. But when you really look at just the plain old packets and how the underlying mechanisms work to actually make that happen on the guts of packet transmission level, we really got to look at it as far as the packet looking like mail. Either being, in this case, it's a direct mailing to the replacement analogy is a direct mailing, and then they respond back with a direct mailing, both of which don't require any sort of signature card. All right, so let's take a look at what it actually means to send a packet and a real simplified level. So this is where we're going to start talking about your actual local area network of what and how the mechanisms in place behind the scenes that let you communicate data between computers on your local network. So my favorite way of looking at it is if you have a campground, and let's say you have 20 RVs, and you just want to mail a letter to a friend that happens to also be at the RV park. Now, the thing is, you don't maybe know which, well, you know their site and all, so you put it on your letter, and when you drop it off, you send the letter, you walk it over, in this case, over the camp office. They're going to look at all the mail from all the campers, and they're going to sort through it, and they're going to say, oh, okay. They're going to check on all the mail that they look at. They're going to check and see, is this letter destined for in the same country, in the same state, in the same city? And then they're going to realize that, oh, wow, after they went from the bottom up on the address of the destination, they say, holy cow, this actually is somebody right here at our own campground. And that's at the street, I guess we'll call street level, in which case it's a local destination. And what we're talking about is the camp office is very much what happens at your router. So it's a local destination at the campground, and they just deliver it right there locally. And the packet basically is handled obviously at the speed of light, but that's the mechanism of how it gets from, generally speaking, from point A to point B in order to facilitate, getting that letter where you want it to go. If it doesn't match, let's say it's an out-of-state address, they immediately stop on the sorting process. The country may have matched, it may not even be listed, it may be assumed. The state didn't match, so now they know, they just send it up to a higher level and somebody else takes care of it, not their problem. So they act as a gateway to the post office, or in this case, the gateway to the internet would be how that packet would be handled. And frankly, the guy at the campground office, he doesn't really care if it matches country, state, or city, because frankly, any one of those that don't match, bang, goes right up. He only really cares, only work he has to do is, oh, okay, this is actually a local packet. Let me make sure I go and walk around and drop it off at the right campsite here. Okay, so how in the world how do you know what campsite you are at, or how is it that you involve yourself on this network? So when you first arrive, so this is like when you first turn your computer on and you get to work in the morning. So upon your arrival, that camper at the campground is going to have to query the camp office. Well, this happens again at speed of light. Your computer says, hey, I'm looking for a DHCP server. I've just arrived in the camp office. Your router downstairs responds and says, hey, I'm right here, and here's an address I'm going to assign to you today. All right, there's your campsite. You've got an IP address, frankly, is the analogy. So you've now parked yourself in the campground, and you know where the camp office is at. Now what happens? Well, the camp office is got a little bit of their smarts as well. They're gonna now also know that IP address, the actual mailing address they just gave to you is within a certain range. They know it's within a certain subnet. We'll talk about subnetting in just a minute. They themselves know they're the gateway, so they'll tell you, not only am I here, not only is it I'm the director of this campground, gave you your IP address, but if you want to send something upstream to the internet, I'm your gateway. So make sure you drop it off at the camp office, here at the router, and I'll take care of sending it upstream. Now, the camp office is also going to help facilitate being in the library. In case you don't know that company that you're looking up, it can actually do what's called a domain name resolution. So that's how the camp office can act as that library. So when you type in you want some website you've never been to, and you don't know the IP address of it, you just know the name of the company, for example, you can actually, the router itself will help facilitate at least looking up the correct IP address of that company that's out in the internet space, and will help resolve that. So when the camp office gives you some information, it always tells you your IP address, how you fit into the world. So it'll assign you a part of its mechanism subnet. It'll say, I'm your gateway. It'll help resolve things, and it'll let you know, hey, I'm your guy to do that for you. And it's always just called, the sorting router when you set it up at home or at the office, right? So now I want to send a letter, like we spoke a moment ago, to somebody, and let's get that thing taken care of. So first thing, the site number itself that's assigned by the camp office, right? That's our IP address, and they'll actually assign that to us. So when they do so, the only unique thing in an IP address typically that your router is going to issue to you is that last number, because they're going to say, okay, here's the things I need to check. I'm in this country, I'm in this state, I'm in this city, and in this case, they actually themselves kind of make these numbers up so they can manage it internally. They have their own world, if you will, right there. and they're going to assign you a unique site address on the network. Now, if you're the administrator on your router, you've actually defined, you've set up your DHCP server, so it's giving out a unique local site address. And in this case, it's assigned to me .100. I'm a user, and that happens to be the IP address of the campsite I just got. Now, that gateway is got its own IP address, right? Because it's got to say, I'm at a location. So when you set up your router, it's going to be at something generally like at a 1.1. So that last number, that .1 is important. You set it up. You're the camp director as the admin, so you're going to set them up at .1. And the subnet is where it gets kind of a little bit tricky at times. But what we're doing as the camp director is I'm going to use these funny mechanisms that I'm going to sort against, if you will, or mask is how they like to say it, against. So when I issue the IP addresses to everybody here at the office, I'm going to use what's called a subnet mask. And it looks a little odd, but the biggest number that you can have in this space is as is shown there. 255 is the biggest number you can have in each one of these little city, state, country areas. That's kind of displayed there. So I suppose you could think of it as a maximum of 255 countries, each of which can only have 255 states in it. Each state can have a maximum of 255 cities, and each city can have a maximum of 255 residents. As a camp director, I only want to manage the number of street addresses within my, if you will, city. Now, obviously, as a camp director, I can try and I have my own little universe, if you will, so I can try and actually go as wide as going 255. So I would give out like 192, and I could give out all these crazy addresses under 192 subnet, but it gets really complicated. So how about we just we're going to just be a city-wide manager for today, and we're going to just pretty much give folks numbers that are in that last place. So what this mask does is it actually allows the campsite director to quickly identify if you're sending mail to somebody that is that's not within this group. So as soon as you send something to a different city identifier, so if I send mail to 72.43.5.18, well, that's an actual IP address of something probably out on the internet, right? That's somebody out there. It's not in the campground, that's for sure, because all that camp director had to do is as soon as they got that, as soon as your router got that IP address, he's like, holy cow, it doesn't even match the country. It doesn't even match anything I've assigned within my universe. So as soon as I know it doesn't match anything here, shooting it out the door and let the internet handle whatever that thing is, and hopefully we get a response back. Maybe we won't, but hopefully there actually is a server out there that IP address is supposed to go to, and in which case you'll get a response back, and the camp director keeps track, if you will, or the router keeps track that you sent this message out, and he's helping to keep track and wait for the response back, and he has it keeps a table, if you will, and those are actually, it's called a port table, and those ports that are in that table is what the router keeps track of, and it's the specific feature of that router that allows him to keep track of, all right, you sent a request out, I'm going to wait and see if you get a response back so that I can, he'll block other things that aren't relevant to the campers of the campground as a firewall, and that's the mechanism that the router is using that protects the campers from all sorts of internet queries that they may not be wanting to get, a lot of the junk mail, if you will. But what he's doing is he's assigning a port that he temporarily keeps open to handle every one of those requests. And when the remote server responds back, that response is allowed to come through the firewall, and he'll actually deliver the message to you. The router will actually allow that message to respond to you. So there's these IP addresses and router port numbers that router uses that he himself manages to keep track of those requests on an outbound as well as on the response basis to allow them back into through the firewall into the campground. So that's, functionally speaking, how a subnet is really managed by your local admin. So here at our company, we don't have more than 255 campers. So we don't issue any. We don't try and go with anything with a subnet mask that goes higher than the 255.255.0. At some point, as you know, if our company were to grow larger and we had different divisions, then we may decide to go with a 0.0 subnet and have to manage a little bit larger area. But then again, we're a larger company with more sophisticated administration. So your typical home router you'll always see this triple octet that you'd see of 255s. All right. So if we really start getting into the detail of how all this is working, so we talked a moment ago about how we had junk mail and how we had direct mail, and then we had direct mail with a responding signature line, if you will, and that if you didn't return the card, they're going to keep trying over and over again until they get that card response, and sooner or later, though, they may just give up on you. Well, that's actually how this whole thing works. So when you're sending a packet or a letter to somebody and it's junk mail, that's just called a broadcast, and that's just means that everybody on your local area network, everybody at the campground, at least in this universe, that your little campground's a little universe, when you send out a broadcast message, everybody at the campground is going to get a copy. Now there might be a bazillion people in the on a local area basis, but broadcast packets happen only in local area networks. All right, and then you've got direct mail. Now, direct mail can be is now at the point where I can give it a unique IP address, because the broadcast stuff didn't have a unique IP address. It just says, hey, everybody should get this. It has basically what's considered a broadcast IP address, and the router basically puts a copy of that broadcast in everybody's mail slot, and then he gives a copy of the junk mail to absolutely everybody there. The unicast is what we spoke about earlier, which is I want to send it to a specific friend at the campground, and it's just going to go there. I don't really know if he got it or not. I kind of assume the camp director is a responsible person. The network is operational, and I'm going to send it, and that's called a UDP packet. It's just goes. It's a unicast packet. It's not a broadcast in this case. It's just a unicast. Hope it worked message. Super good for doing streaming video and audio. Really not good if you're trying to transport a file and you want to really make sure the file gets to where you want it to go to, because that's an important feature of a lot of packet transfers that occur in networking. So what you find is the important stuff usually has signature mechanisms, and those are just called it's a response packet, and it's very common. They're very, very small response packets that happens very quickly, but it ensures you've got quality communications that are going across the network. And in the majority of cases, it goes the first time, you get your ACK, your acknowledgement, and then you just send the next piece or the next file, and over again it goes back and forth. It makes for very high reliability, and it has an additional feature, which is that if you're overwhelming the camp director and he can't keep up in delivering the mail, it's just not fast enough. This is more often a case on the internet where you're requesting data from a server, the server's unable to respond, or it just gets lost. You can keep asking over and over again until you get a response, and that way for sure that data is traversing. But it has this neat thing, is it acts as it has an auto-throttling sensing mechanism, right? Because if you're sending more data than your upstream pipe on your router to the internet can handle, you're just not going to get responses. So sooner or later, you're going to just slow down your requests until you're able to successfully get your transmit ACK mechanism to work properly. In contrast to just a unicast, a UDP packet, which is unicast to go out to the internet. So it has to be going to a specific site, because broadcast won't go out the router to the internet. It can be UDP, which allows it to be direct mail with no acknowledgement. So let's say I'm sending a truckload of UDP packets. Well, I don't know if they get there or not. And that's the problem, because our upstream pipe for example, our outgoing the mail truck, if you will, that picks up the data at your camp office might not be big enough. And that's kind of the idea of your upstream issue, is that you're sending too much junk, and the little truck that's going and bringing it upstream just can't handle it. And you have no idea that all that mail you're sending is just going basically nowhere. It's just vaporizing because you can't fit it all in the truck. And you had no idea because you're just sending it out blindly, and it's just hitting the floor and vaporizing right there as your router before it can even go upstream. So UDP is can be very challenging, because if it were to be a video stream from a remote camera that is just doing a UDP blast and you're trying to view it and you're only getting fractions of the video feed of this UDP stream, you're going to get really annoyed and not necessarily know, well, why am I not getting my video? Well, it's disappearing someplace because there just isn't, there's a bottleneck somewhere, and it requires manually logging in generally to the camera, slowing it down by hand and saying, okay, I think I can handle about this much data without much loss, if you will, of packets due to overrunning my bottleneck. And in which case, if you get it, you dial it in, and hopefully you get it just about right. If there's a burst of other data going out, the video is going to kind of shiver for a bit until it can actually get the bandwidth back that you set it that it needed. So that's why we really love to see folks even doing video to do TCP, because it's able to kind of auto-modulate itself to make sure that it's not sending too quickly, because it won't send the next packet until it successfully gets that response, right? So it'll slow itself down automatically. So if we go in just a bit deeper into what really is happening behind the scenes, because to be honest with you, data doesn't really go across the internet via IP. IP is what helps which is how it is that you send data over the internet. And honestly, it's how data goes when you need to go past your router. When you're on your local area network, IP is really only used as an initial mechanism, so you can actually communicate through your router to the other devices on your network on the initial communication. Because what happens after you do so, and you ask your network and you say, hey, I'm looking to talk to you and send a message to my neighbor. Now, I was assigned .100, and this is where you get into the nitty gritty, because I'm now saying I'm going to send out a message, and I'm going to say something of the order of, hey, I'm going to broadcast it to everybody at the campground, say, hey, I'm .100, and I want to send a message to 120. And what'll happen then is everybody heard that message, but only want .120, right? That particular camper, your friend, is going to come back and say, hey, I'm over here. But when he responds, he's going to say, I'm over here, but he's actually going to give you back his specific MAC address. And these MAC addresses are really how it is that data goes between the two devices now. So what will occur in this case is you've made this broadcast request. Your friend got back to you with his, and remember, broadcast only works on a local basis. So he was local, he heard your broadcast, respond back, you now have his MAC address. And what happens is that he is unique in that MAC address. He is one of a kind. As a matter of fact, every single device you own and I own and everybody owns is drawing from this pool of MAC addresses. Since day one of Ethernet, there's been these MAC addresses. And luckily, there's 281 trillion of them. So we haven't quite run out yet, but it's getting there. And sooner or later, MAC addresses are going to be in short supply. But so far, there's still enough remaining of the 281 trillion available MAC addresses. And a typical MAC address, you can see, is shown on the screen there. And literally every device has one of these unique identifiers. So in order to send data back, that initial query that I was talking about a moment ago is super small, tiny little broadcast packet. I got the response back, another super tiny little broadcast packet. Nobody cared that these little flashes of data went across the network. They were insignificant compared to the capacity of your network. And now I get to actually send real data. And now that I can send real data, I'm going to send it to that specific MAC address. So every packet now actually is addressed specifically to my friend at that MAC address. And because of how switches work, he'll be the only one that actually gets a copy of it. Regardless of if the packet's a unicast or a broadcast, at this point, it literally goes just between he and I don't even need the camp office to do it. I can directly make a data connection through the switch to that other friend that's on my local area network, and we're going to send data back and forth and transfer files as much as we want. So then the idea being is, well, what about those internet packets, Mike? And here's how the magic works here, and why IP has enabled such an amazing transformation of local area to wide area networking 25 years ago, and why Cisco made $1 bazillion. But here's functionally speaking what the router just did for us is I have this what would be considered a local area IP address, and I want to talk to something that's on an IP address range that's out of my subnet. And it could be that funny number I talked about a moment ago, 72 dot blah, 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 blah. So what I do is I ask and I send out one of these messages to my router, and I say, hey, can you help me figure out what MAC address this IP address goes to? And what then occurs is your router, which got an IP address assigned to it from the Comcast or your internet service provider, assigned your router an IP address, and it's going to look at that IP address and say, well, it definitely isn't local to my group. I'm going to send it upstream, and then somebody up there, because he knows the MAC address of his router and his gateway, he's going to send that request up to via MAC address. The packet's actually going to transmit from you to your router to his gateway to some other gateway who's finally going to know what to do with that IP address, and it'll finally match something that is on their local area group. So it keeps bouncing between upstream routing devices via MAC address, and because everybody is able to query an upstream gateway or router and they participate in that manner, they're able to sit there and figure out, how the heck do I get to this IP address and resolve to figure out its MAC address to transport. So every packet moves from one router up to the next, across to the next, back down to the next, over to the next, and then finally to the final device, all in a point-to-point, MAC-to-MAC communication basis. And they just keep the tag, if you will, the IP address as the actual destination within the packet, because that's what where you're trying to go. But all of the devices between here and there are all handing them off between each other, MAC address to MAC address, because they are able to query their upstream router and ask for its MAC address, and then they bang it around. And that's really, believe it or not, how Ethernet really works behind the scenes, is data traversing MAC address to MAC address. Well, that's all the time we have today, and that really was the extent of how far I thought I could get in 30 minutes. There's a lot more behind the scenes as far as of how to go through and resolve ideas about making port forwarding rules in order to get to remote devices. I was hoping to get that far. I think I'll set up coming forward. We'll have maybe a more advanced session where we talk more in detail about potentially port forwarding and some of the other technical nuances of more advanced networking. But that's what we have time for today. Appreciate everyone being involved, and would be delighted if there's any questions at this time that I might be able to help folks with.